Hi there, I'm Scott Morrison, CTO of FIMI Technologies, and today we're going to talk about the ideal architecture for sensitive big data. So this is an architecture that we actually advocate a lot here at FIMI, and in fact it mirrors a lot of what analysts have been talking about for a while. What it does is it breaks the architecture up into three critical zones: an ingestion zone for data, a transformation zone where you manufacture new data sets, and an analysis zone, mainly concerned with making sure that only the right people can see the right data at the right time. Now let's bring this all together and talk about the flow of data through this system. Now, any big data system and any big data workflow is ideally going to be able to pull in data from a lot of different sources, different machines, different IoT devices, but it's also going to come in with all sorts of different structures. It's really broken up into three distinct zones: an ingest zone for data, a transformational zone, and finally an analysis zone. And sometimes you may have really interesting styles of data, like let's say genomic data, which is very unusual, very large, and requires very specialized techniques. Regardless, you should be putting them all into one place because the value of the data is realized when you can start to make connections between things. So let's start with the ingest zone. Now, the critical consideration here is you have a lot of different systems that you're actually going to have to bring data in. Some will be synchronous, some will be asynchronous. Some you'll have nice streaming data coming in. Some you'll actually be just going out and getting batch files. It shouldn't matter. You should be able to integrate all of that together. Now, when you bring it in, the most important thing to do is to classify the data as soon as it comes into the system. Now, by classifying, what I mean is you could be putting in where it came from, under whose responsibility the data was taken, and the date that it was acquired. But you also want to be able to put in security labels that actually describe the relative sensitivity of the data. Now, some of it could be public information available for anybody to look at. But some of it could be, well, secret or even top secret. Now, it doesn't matter what your labels are, but the point is you're going to be using those later as a way of gaining access to that data. So it's really critical that the moment the data comes in, all of it at a very, very fine granularity is actually labeled appropriately. So once the data comes in, the other important thing to consider is you've got to keep it around for a long period of time. It's really, really important to recognize that that initial landing right there, that data should be immutable. It should not be transformed in its own right. You can create new data from it, but you should always have the original data so that you can reference back to it. Now, that doesn't mean you don't necessarily move it off, let's say, into a data glacier or something like that, but you should be able to bring it back if you need it, and it should be in its exact original form, pure and unfiltered. Really, really crucial idea. The next stage, of course, is transformation, and this is where the real compute horsepower comes into a system like this. This is where you might be doing filters and joins and combining multiple tables and things like that, all down to something that's useful for somebody to analyze. Another thing that goes on in transformation is manufacturing data sets for a particular use. And this is really crucial because this is where you have to look ahead and decide who's going to be accessing this data and what are their rights and entitlements. A good example might be, I might be pulling in medical records from a lot of different locations that I want to make available to a particular researcher to, say, look for a cancer cluster in a particular region or something like that. But it would be very crucial to actually go through ahead of time and de-identify that data. So in other words, remove any possibility of that researcher figuring out who an individual is. And they in fact don't need that information, but there's still data or value locked up in that. So having good de-identification capabilities within your system as a native part of your platform, absolutely crucial, because making data basically be targeted for a particular use is a really, really important function in this whole thing. Now, finally, we create new data sets, we basically target them for analysis and move them into the analysis zone. The analysis zone is fundamentally all about access control. You've got lots of different researchers, lots of different people who need to look at data, but each of them has different entitlements and different reasons to see the data. What's important here is we make sure that only the right people see the data that they're entitled to see. And to do that, the best approach is to use an attribute-based access control system. Now, ABAC actually takes all of the attributes of a person, like let's say what their pay grade is, or what their rank is, or what their entitlements are. They combine that with those security labels that I was talking about. Maybe the data is public, maybe it's secret, maybe it's top secret. And they combine all of that under a rule set called a policy. Now, the beauty of ABAC is that it makes these decisions in a very, very scalable way. You can have hundreds, thousands, even millions of users, and the system still scales very, very effectively, particularly if people are coming and going all the time. So taken together, if you put all of this together, you've got a very, very strong platform for actually governing sensitive big data. So if you're interested in something like this, take a look at FEMI Central. What we do is we build turnkey platforms so that you can do this kind of analysis on big data, regardless of the data types coming in here, and regardless of the number of people you have that actually need access to it. So FEMI Central, it's the right way to do big data.